We are on problem 63. The height of a triangle is 4 inches greater than twice its base. Let me draw this triangle in question. So let's see. So let me draw, that's the triangle. That's its height. That's its base. So let's say the height is 4. So if this is the base, let's say this is the base. Let's call that B. So then the height, that's that. The height is 4 inches greater than twice its base. So 4 inches more than 2 times the base. Fair enough. The area of the triangle is 168 square inches. What is the base of the triangle? So what's the area of a triangle? It's the base times the height times 1/2. So area is equal to 1/2 base times height. Well, they told us that the height is 4 more than twice the base, so we could just substitute that in, and then we'll have it just in terms of the base. We keep that there. So the area is equal to 1/2 the base times the height, which they told us is 4 more than twice the base. And now if we distribute the 1/2 b, we get area is equal to 1/2 b times 4 is equal to 2b. And then 1/2 b times 2b, that's plus b squared, right? 1/2 times 2 is 1, and then b times b is b squared. Fair enough? And they tell us that the area is 168. Okay, so we have area is 168, and that's equal to 2 times the base plus the base squared. Let's swap the sides just to make it look a little bit familiar. B squared plus 2 times the base is equal to 168. See, we could subtract 168 from both sides. You get b squared plus 2b minus 168 is equal to 0. And 168 is a bit of a strange number. I don't know exactly which numbers go into 168. Let's see, it looks like 4 would go into it, what? 4 would go into it 40. 4 isn't going to work. Let's see, 12 goes into 168. Let's see, 44, 12. Does 12 go into it? Yeah, 12 goes into 168, and I think it goes into it 14 times. Right, so that works. So you could use a quadratic equation to solve this, but I think that 12 times 14 is 168, and they have to be of different signs since this is a negative, right? You have only different signs when multiplied get you a negative number, and they're 4 apart. They're 2 apart, so that works out. So you get b plus 14 times b minus 12 is equal to 0. And let me just to confirm and not waste your time. 14 times 12. I'm pretty sure I'm right. Yeah, 168. I just factor that out. So b could be equal to minus 14, right? That would make that 0. Or b could be equal to 12, which would make that 0. Now, obviously, if you can make one of these terms 0, you're making this whole thing 0. And the base, since we're doing with, distances or lengths, we can't have a negative length. So the base has to be 12, whatever, 12 inches, which is choice C in that question, right there. 12 inches. Next question, problem 64. 64. All right. So this is a good one. All right. What is that thing reduced to lowest terms? So essentially what they want us to do is factor stuff out and factor it out and write it as a product of factor, then cancel out the ones. So let's see what we can do. Can we factor that top expression? Let's see. This looks like a perfect square, right? Because if you have minus 2y squared is 4y squared, and minus 2y is minus 4y. So this should be the top expression is x minus 2y squared, and I'll just write it twice because I'm guessing that one of them are going to have to be factored out, x minus 2y. And once again, the intuition is that, let's see, if I had this, x squared minus 4x plus 4, you say, okay, what two numbers, when you multiply them, equal 4, and when you add them, equal minus 4? You say, oh, minus 2, and you would say, oh, that's equal to x minus 2 and x minus 2, right? The only difference between that and that is they put y's here. Y and a y squared. And then you say, okay, so let's treat 4y. So you could visualize this thing as x squared minus 4y x plus 4y squared, right? Or you could visualize this as x squared minus 2 times 2y x plus 2y squared, right? Oh, this isn't 4y squared. This is 4y squared. forget the parentheses. But I hope you can see that this thing up here is the same thing as this thing right here. And that's where I got the intuition that that's going to be x minus 2y times x minus 2y, right? You say, okay, what two numbers when you add them are 2 times 2y? Well, obviously 2y. And what numbers when you square them is 2y squared? Well, 2y times 2y is 2y squared. So that's where you get the intuition. That's x minus 2y times x minus 2y. All right, that's the numerator. Now let's see what we can do with the denominator. The denominator. Well, immediately both factors are divisible by 3, and both terms are divisible by y. So let's factor those out. So this is equal to 3y. Now, if you divide this term by 3y, all you're left with is an x, right? 3xy divided by 3y, you just have an x. And then if you divide minus 6y squared by 3y, you're left with minus 6 divided by 3 is minus 2. Y squared divided by y is y. And let's see. If we assume that x does not equal 2y, right, because then this would be undefined, we can cancel these two out. And you're just left with x minus 2y over 3y. And that is choice B. Problem 65. Problem 65. They want us to do it again. Okay, let's see. They want us to do it again. So this top expression, let's see, everything's divisible by 3, so let's rewrite it. Let's factor out a 3 there. So it'd be 3 times 2x squared plus 7x, right? 21 divided by 3 plus 7x plus 3. Let's see, what's the bottom one? Well, this fits the pattern, a squared minus b squared, right? A squared minus b squared. This is something squared. 4x squared is 2x squared. And then 1 is obviously 1 squared. So we could write this as equal as a plus b times a minus b. And what that would be 2x plus 1 times 2x minus 1. Right? 2x squared is 4x squared, and 1 squared is 1. So let's see, we factor that top part, and I'm guessing it's going to cancel out with something in the denominator. So let's see what we can get. This is equal to, let me do it on the side here. So if I had to factor 2x squared plus 7x plus 3, so it's going to be 2x plus something times x plus something, right? Because the 2x times the x is 2x squared. And the b times the a is going to be equal to 3. And so I'm guessing one of them is going to be a 3, and one of them is going to be a 1. And I could already guess it, but we could do a little bit more systematically on how this is going. So let's multiply it out. 2x times x, 2x squared. 2x times a plus 2ax. B times x plus bx. B times a plus ba. So you get 2x squared. And I merge these terms. Add the coefficients. Plus 2a plus bx. Right? That's those two terms. Plus ba. Is equal to this thing up here, is equal to, I'll write it right below it so we can compare terms, is equal to 2x squared plus 7x plus 3. So what could a and b equal? See, 2 times a plus b is equal to, so if a is 3, if this is 3 and this is 1, 2 times 3 is 6 plus 1 is 7, works, and then 3 times 1 is 7. So b is 1 and a is 3. So this is a 3 and this is a 1. And you could multiply that out if you're not comfortable with it. But anyway, we could rewrite this top thing as 3 times, and we did the factoring here. We figured out that b and a are 2x plus 1 times x plus 3. All of that over 2x plus 1 times 2x minus 1. And we know we're on the right track because we've got something to cancel out. And sure enough, so we cancel those out, assuming that this never equals 0. This x does not equal minus 1/2, because that would make that equal 0. And we get 3 times x plus 3 over 2x minus 1. And that is choice B. Choice B. Let me see the next problem, see if we have time to do it right now. Oh, it's another one of these. I'll wait for the next video. See you soon.